For today's experiment, we are using these apparatus and materials. Fill the largest well of the well plate with dilute magnesium sulfate solution. Add universal indicator into the magnesium sulfate solution. Connect 2 batteries to 2 graphite rods using wires with crocodile clips. Insert the 2 graphite rods into the magnesium sulfate solution. The graphite rod connected to the positive terminal of the battery is the anode, and the graphite rod that is connected to the negative terminal of the battery is the cathode. Effervescence can be observed after a while at both anode and cathode. The effervescence at the anode is less intense than that at the cathode. The solution surrounding the anode has turned from green to pink, while the solution around the cathode has turned from green to purple. The solution away from the electrodes remains green. There are 4 types of ions present in dilute magnesium sulfate solution. They include magnesium and sulfate ions from magnesium sulfate and hydrogen and hydroxide ions from water. The negatively charged ions, sulfate and hydroxide ions, are attracted to the positively charged anode. As hydroxide ions are lower than sulfate ions in the electrochemical series, hydroxide ions are selectively discharged to produce oxygen gas and water as shown in the half equation. Effervescence is observed as oxygen gas is produced. During the discharge of hydroxide ions at the anode, the concentration of hydroxide ions becomes lower than the concentration of the hydrogen ions. This lowers the pH, causing the universal indicator to turn from green to pink. The positively charged ions, magnesium and hydrogen ions, are attracted to the negatively charged cathode. As hydrogen ions are lower than magnesium ions in the electrochemical series, hydrogen ions are selectively discharged as hydrogen gas as shown in the half equation. Effervescence is observed as hydrogen gas is produced. As hydrogen ions are discharged at the cathode, the concentration of hydrogen ions becomes lower than the concentration of hydroxide ions. The pH increases, causing the universal indicator to turn from green to purple. From the reactions that occur at the anode and cathode, the overall equation is as shown. The equation can be simplified into this. From the overall equation, we observed that the ratio of hydrogen gas to oxygen gas produced is 2:1. Therefore, hydrogen gas produced at the cathode is more than the oxygen gas produced at the anode in a fixed time.